All right, back. I had to change some batteries in my microphone. Anyhow, we talked about our variables, or our different vocab terms. So you think about a vending machine. I'm going to give you a very simplistic example. Let's say here's my vending machine, and over here's the buttons I push. I've got A1, A2, B1, B2, and then over here in the vending machine I've got A1, A2, B1, B2, and let's say maybe you like, we got Skittles here, and we got Twix, and let's say what else we got in the vending machine. Maybe we have licorice, and we'll go Snickers, just to keep things rolling. So if you think about our example of our vocab words, the domain, the possible inputs, what are the possible buttons I could push in? A1, A2, B1, B2. The range, what are the possible candies that could come out of the vending machine? Skittles, Twix, licorice, and Snickers. Now, to be a function, remember something, to be a function, every input can only have one output. If I press A2, what do I get out? Twix. If I press B1, what do I get out? Licorice. In our example, every input has its own output. That's good. That's functioning properly. If I were to hit A2 and both Twix and Skittles came out, that's really cool for me, but the bottom line is the machine wouldn't be functioning properly. That wouldn't be a function. So we'll get into those types of examples in a little bit. Jump to example 1. It says identify the domain and range of the function. Input-output table shows the temperatures over various increments of time. Identify the domain and range of the function. Again, domain. What are the set of the inputs? In this case, we'd have 0, 2, 4, and 6. Your range, we go out to the Gulf range. Your outputs are 24, 27, 30, and 33. In this example, again, they ask us to identify the domain and range. Domain would be your inputs, and your outputs, the possible outputs, just like the candies that can come out. In this case, the output numbers, the range, 10, 20, 35, and 45. Now, range is different than maybe you thought of range as previous math classes. In other math classes, you may have learned the range was the largest number minus the smaller number. In this case, that'd be 35. It's a totally different definition of range. When we're talking about functions, the range is the set of all outputs. In this case, 10, 20, 35, 45. Jump to example 2. Can you tell whether something is a function or not? Again, think of your vending machine. If I press a button, only one thing comes out. If I look at this example, is it a function? Well, when I press 4, I get 1. When I press 8, I get 2. When I press 2, I get 3. Every input only has one output. So letter A, yes, this would be a function. Letter B is not a function. Take a second to look and see if you can tell why. Hopefully you recognize that here is an input value of 2 that has 2 output values, both 2 and 4. So because 2 gives me 2 and 2 gives me 4, again, that would be like vending machine. I pressed a button and out came 2 and 4. It's not functioning properly. That's why B is not a function. How about these checkpoint problems? See if you can take a look and decide, are they a function? Hopefully you see in number 2, if I press 5, it gives me 3, and if I press 5, it gives me 4. There's an input with 2 outputs. That can't happen in a function. And in number 3, every input only has one output. Therefore, yes, this is a function. Now, before I jump to here, I'm going to try to give you a little trickier one here. Let's call my x, and let's call this my y's. Here's my inputs. 0, 1, 2, and 3. And my outputs, my y values, or my range, is going to be 5, 5, 10, and 15. Is that a function? Think about it for a second. Does every input only have one output? Hopefully you're thinking to yourself, yes, this is a function. Why? Well, when I press 0, I only get a 5. When I press 1, I only get a 5. And the other ones aren't really questionable. I think where people usually get mixed up is right here. Every input has only one output. It just happens to be the same output. My example that I like to draw a parallel to is if Snickers are really popular, the vending machine company is going to give you 2 buttons that could kick out Snickers. They're going to have 2 rows of Snickers because they're so popular. So if I press button 0, I could get Snickers out. If I press button 1, I can get Snickers out. As long as I can't press a button and get 2 different things out, then it's a function. So now we want to be able to represent functions. We've seen them in table format. Can we write rules for them? So verbally, if I said the output is 2 less than the input, output is 2 less than the input. Well, let's think about table-wise first. The output is 2 less than the input. 2 less than 2 is 0. 2 less than 4 is 2. 2 less than 6 is 4. 2 4 is, oops, that wasn't so good. Here we go. 0, 2, 4, 6, 8. Who do we appreciate? Here we go. Output is 2 less than the input. Hopefully you've learned some translation pieces in other classes and also in sections 1.3 and 1.4. But remember, our output variable in algebra, we're going to signify that with y. And then you've got this key word in math, is, means equals, 2 less than the input. Well, the input variable we talked about is going to be x. So how do you represent 2 less than x? Not 2 minus x, but 2 less than something, you have to take away 2 from it. And now we've got an equation where we could say, hey, if the input's 10, how do we get that output? Well, 10 minus 2, it gives you that 8. So looking for those key words. Jump to example 3. Domain of the function y equals 3x is 0, 1, 2, 3. Make a table for the function. We can do that really quick. Domain, what am I supposed to plug in for x? 0, 1, 2, and 3. Now we have to come up with the range or the outputs. Okay, the outputs, let's see, 3 times x. Y is 3 times whatever x is. 3 times 0, 0. 3 times 1, 3. 3 times 2, 6. 3 times 3, 9. Range, that's the set of all your outputs. In this case, 0, 3, 6, and 9. Okay, jump to example 4. Again, we're going to try to write a function rule. Look for a relationship. Do you see any relationships between the inputs and the outputs? 3 goes to 6, 5 goes to 10, 7 to 14, 9 to 18, 11 to 22. Hopefully you recognize that each of the outputs is twice the input. So each output is twice the corresponding input. So when we're writing a rule, translate that. Okay? Each output, which is our y variable, equals twice the input. Twice the input would be 2 times the input. Remember, the input variable is x, so we've got 2x. Y equals 2x gives us a rule for this function. Okay, jump to checkpoint problem number 4. See if you can come up with a relationship in this one. I can't just say add a half, oh, that doesn't work because this one's adding 1, this one's 1 1/2. Now check for multiplication. 1 times, well, 1 1/2 would be 1 1/2. 2 times 1 1/2 is 3. 3 times 1 1/2 is 4 1/2. Hey, we've got our rule. Each output, or y, or cost in this case, is 1 1/2 times the input, or the number of yards. So we'd say y, the total cost, is going to be 1 1/2 times the number of yards I buy. Okay. We're going to disregard what happens to the output as the input increases by 1 for right now. So I'll finish off with an example here. Isabel Dean has some money in her piggy bank. You don't have to write this one in your note-taking guide. She's been doing some babysitting. We're supposed to write a function for the amount of dollars she has after babysitting for h hours. So we want a function for dollars. How do I figure out how many dollars she has? Based on how many hours she's worked. So you always check for multiplication first. Or you check for addition first. Can I quick just say plus 10? Well, no, that doesn't work here. Can I multiply 0 to get 10? No, you can't. So then you have to look for a relationship. Okay, then you want to look and say, well, what's happening every time? Every time I go up by 1 hour, how much more money does she have? And in this case, you notice, oh, 10 to 15, that's plus 5. 15 plus 5 is 20. 20 plus 5 is 25. Going up 5 every time. And there I gave you the clue to unlocking how to write the rule for this function. I go up 5 every time. I like to emphasize the word time because times 5 is going to be part of your equation. But that's not it, because if I took 5 times 0, well, that gives me 0, not 10. So how do I make 10? If I put 0 in for h, 5 times 0 gives me 0. How am I supposed to transform that into 10? Well, I have to add an extra 10 bucks. Check it for another value. 5 times 1 is 5, plus 10 gives me that 15. Let's try 2. 5 times 2 is 10, plus the extra 10 gives me that 20 bucks. So So essentially this $10 represents how much money she already has in her account, and she's gaining $5 for every hour she babysits. So look for those relationships. Can I just multiply the input to the output? Can I just add? If not, check and see what happens every time, and that'll unlock if multiplication is a part of your rule, and then you might have to adjust with a plus or minus at the end. All right, hopefully you got your notes taken care of. We'll see you in the morning.